Welcome back to our special series on electromagnetism. In this segment, we'll explore the challenges in building harassment devices that combine jammers and EMPs. Joining Joanna is our expert, Brian, who will discuss the main technical challenges, approaches to solving these hurdles, and strategies for risk assessment and mitigation.
Brian, let's start with the main challenges in developing a device that combines jamming and EMP capabilities for harassment purposes.
Developing such a device involves significant technical challenges. First, there's the issue of signal generation and frequency management. Generating multiple jamming signals across various frequencies, such as cell phones, Wi-Fi, and GPS, requires precise control and coordination. Then there's the power supply and energy management. The device needs a robust power supply to support both continuous jamming and high-power EMP bursts without overheating or running out of power quickly.
How can these technical challenges be addressed?
For signal generation, a programmable signal generator capable of producing a wide range of frequencies can be used, along with software-defined radio, SDR, technology to dynamically adjust frequencies and power levels in real time. For power supply, a hybrid system using high-capacity batteries for continuous operation and capacitors to store and release energy for EMP bursts is effective. Efficient power management circuits are crucial to balance the load and prevent overheating.
What about the challenges related to EMP generation and beamforming?
Creating controlled EMP bursts that are powerful enough to disrupt electronics without causing permanent damage or posing health risks can be achieved using controlled discharge methods like a Marx generator or an explosive-driven magnetic flux compression generator. Safety mechanisms to limit the intensity and duration of the pulses are essential. For beamforming, a phased array antenna system with adaptive beamforming algorithms can be utilized to achieve precise directional control, minimizing collateral impact. Real-time feedback mechanisms help adjust the beam dynamically based on environmental conditions and target movement.
How can heat dissipation and cooling be managed in such a device?
Incorporating advanced cooling systems, such as heat sinks, fans, or liquid cooling, is necessary. The device should be designed with thermal management in mind, using materials with high thermal conductivity and ensuring adequate ventilation to manage the heat generated by continuous operation and high-power bursts.
Let's discuss the legal and ethical challenges. What measures can be taken to address these?
Ensuring the device does not violate laws and regulations regarding the use of RF and EMP devices is paramount. Thorough research and compliance with local and international regulations are required. Obtaining special permissions or licenses, if applicable, and designing the device with built-in safeguards to limit its operational range and power to comply with legal limits are necessary steps. Safety protocols, including automatic shut-off mechanisms and shielding to contain the EMP effects, are crucial to prevent harm to humans and unintended electronic devices.
What about the ethical implications of using such a device for harassment?
Addressing the ethical implications involves advocating for the responsible use of technology and educating potential users about the ethical and legal consequences of misuse. Promoting the development of technologies for positive and constructive applications is essential. Emphasizing responsible use and the importance of preventing misuse is crucial to mitigate the ethical concerns.
How should the development process be approached to ensure these challenges are managed effectively?
The development process should start with a comprehensive needs assessment to define the specific requirements and constraints of the device. Detailed schematics and simulation models should be developed to predict performance and identify potential issues. Sourcing high-quality components and conducting rigorous testing in a controlled environment to validate the design is necessary. The design should be optimized for efficiency, robustness, and ease of use, with all necessary safety features implemented to comply with relevant regulations.
Thank you, Brian, for discussing the challenges and solutions in developing harassment devices. In our next segment, we'll explore societal skepticism about directed energy weapons and the psychological and cultural barriers to acceptance. Stay tuned as we continue to uncover the fascinating world of electromagnetism.